Hello, I'm Tanzia, the lead of Team SafeLink, the designers behind Project Rest, Recover, Empower. Team SafeLink is a diverse group of undergraduate engineering and architecture students from Monash University in Australia, and we're passionate about designing safe housing communities for Australians in need. We're a team of 17 students, but presenting with me today is Sav, Lucille, Jamali, and Cheyenne to step through our design. Project Rest, Recover, Empower, or Project RRE, is a purpose-built refuge for women and children experiencing domestic violence. These key values, rest, recover, empower, guided us to create a residential complex where these women in need can rest, where they and the environment can recover through sustainable design solutions, and ultimately where all occupants and stakeholders involved can be empowered. Statistics show that it takes an average of 7 attempts for a woman to leave an abusive situation. Given that there are waitlists of over 2 weeks for current domestic violence refuges, Project RRE meets the desperate need for dedicated refuge housing in Victoria, providing a place of stability and support for families who are forced to escape from dangerous situations. 41% of people seeking help from specialist homelessness services in the last year were experiencing domestic and family violence. These situations could only have worsened with extended lockdown from COVID. Working with Cara House, a not-for-profit organisation which provides support and temporary housing for victims of domestic violence, we have designed an attached housing complex to cater to women of all ages and cultural backgrounds, inclusive of women with children, disabilities, and those identifying as LGBTQI+. As a government-funded facility, Project RRE is the first of its kind to provide dedicated, purpose-built spaces to support these women in need. For our site, we selected a plot in Oakleigh East, a residential suburb within the city of Monash that has a population of 6,500 and is located 10 miles southeast of downtown Melbourne, the capital city of Victoria, Australia. The plot is centrally located within walking distance to shopping districts and 13 public bus routes, with train routes a further 10-minute bus ride away. Close to the local police station, local schools, libraries, and health and government services, Oakleigh East is a safe, low-crime area that provides easy access to all the services an occupant of the refuge would require. Oakleigh East is within the metropolitan Melbourne area within the Australian Climate Zone 6, the equivalent to the US Zone 3C. It has a temperate climate categorised by moderate rainfall and limited temperature extremes. Located in the Southern Hemisphere, winter occurs from June to August, where Oakleigh East has an average daily minimum temperature of 43 degrees Fahrenheit, with summer occurring from December to February with an average daily maximum temperature of 78 degrees Fahrenheit. Having 2,700 heating degree days and only 450 cooling degree days means that heating is a greater consideration for the design. Approximately 29 inches of rain falls evenly across the year, making it suitable for rainwater harvesting. If you're not familiar with Melbourne weather, it's known for experiencing all 4 seasons in one day, with weather conditions never lasting long and the sun coming out to shine for over 2,200 hours per year. This makes it an ideal climate for solar energy generation, which is the cheapest and most reliable renewable source for Australia. The Project RRE building was designed in accordance with the 2019 National Construction Codes, which contain the Building Code and the Plumbing Codes of Australia. These provide the minimum requirements that must be met for all new buildings throughout Australia. The refuge is classified as a Class 3 residential building and is therefore required to meet additional fire safety and accessibility standards. In order to accommodate for occupants and staff with disabilities, we've designed a dedicated accessible unit and made sure that the multipurpose areas and staff space meet the highest standard in the Livable Housing Australia guidelines for disabilities. Additionally, the building adheres to local council planning regulations within the Monash planning scheme, and to meet the requirements of the DOE Zero Energy Home, the prescriptive path was taken and comparisons were made between equivalent Australian standards when necessary so that we could meet all exhibits. Hopefully that's provided you enough context for the project, and I'll now pass on to Sav, who will go through our design goals.
Project RRE follows 5 key design goals, which address Cara House requirements. The most imperative goal was to create purpose-built spaces, such as the multi-purpose room for group therapy, restroom gardens, and dedicated staff areas to manage the refuge operations. Within the units, it was important to create a comfortable space that was suited to short-term occupancy periods, and Cara House emphasized how it was necessary to balance not being too comfortable or luxurious, as the goal was to get women back up on their feet and out of the refuge quickly, so they can continue their journey of recovery. Flexibility is a key design principle that sets our project apart. Our Occupancy Maximizer layout allows a standard 2-bedroom unit to be converted into a 1 or 3-bedroom unit using an operable wall. This allows Cara House to adapt the units to varying occupant profiles, and accept women at the top of the waitlist. It also ensures that the complex maintains optimal capacity across the year and decreases wait time for women desperately needing a safe place to stay. Given the dangerous situations these women are escaping, security and privacy were prioritized. This is done actively using security cameras and keycard access points, as well as passively through the site design. A U-shaped site layout provides an enclosed area hidden from the street, and the communal garden creates restorative areas of seclusion while also maintaining visibility to monitor occupant well-being. The complex was designed to be easy to operate and maintain to smoothen the transition between occupants, which occurs every 4 to 6 weeks. The staff space allows 24/7 staff supervision, and the units have minimal storage and easy-to-clean surfaces to reduce changeover periods. The last consideration was to make sure the design appeals to all stakeholders of the refuge, not only the occupants and Cara House who will be using the refuge, but also the government who will be funding the project, and to demonstrate how net zero refuge can be more efficient and cheaper over the long term. I'll now hand it off to Lucille to talk about the rest aspect of our project.
The first major focus of the project was creating a residential space where the occupants can rest. Project RE has been designed as 3 blocks. Block A contains 4 standard 2-bedroom units, Block B has 3 standard units and 1 accessible unit, and Block C contains the multipurpose and staff spaces to meet the operational requirements of the refuge. In the center of the blocks is a communal garden to suit children of all ages, as well as an accessible pathway covered by a timber-roofed pergola, providing access to each unit. The covered car park and vertical slab fencing help to blend in with the surrounding buildings and create a continuous front facade. There are 8 2-story residential units, all with an identical layout, except the 1 accessible unit which has greater clearances to accommodate wheelchair users. Each standard unit has 2 bedrooms, a fully functional kitchen, a bathroom, and 2 living spaces, 1 upstairs and 1 downstairs, as well as a private backyard and balcony space. Occupant safety has been prioritized with high balcony railing and wall-mount stair gates. To meet more workplace equality requirements, a residential lift has been included for the staff space for use strictly by those requiring it. In addition to the residential unit, a dedicated multipurpose and staff space have been designed for the operation of the refuge. These spaces include interview rooms so that Care House can assess potential occupants for their suitability, child play areas, shared computer for occupant use, and a flexible space for group therapy and other activities. Upstairs is the staff office with a kitchenette and 1 staff bedroom and bathroom so that 1 staff member can remain on site at all times as per refuge requirements. In the center of the complex is a communal garden that contains a natural playground for small children and a small basketball and soccer net for older children. Sitting out the front of each unit and the multipurpose space allow occupants to supervise the children as they play and create opportunities for interaction. The key design in Project RE is Occupancy Maximizer layout that changes which unit has access to the upstairs bedroom through the use of an operable wall and ceiling rails. The operable wall has retractable horizontal pressure seals and edges that interlock with the permanent walls to ensure a tight seal for heat and sound control. A hidden keyhole allows the door to be locked in place, and only Care House will alternate the positions during occupant changeovers. The site has been designed so that there are 2 building envelopes so that subsystems can be shared across the units. This allows all utilities to be centralized along the adjoining wall of a 2-unit duo. Water efficiency strategies have been implemented through the installation of water-efficient appliances and fittings, with low-flow taps and shower heads, and a small dishwasher to suit the expected occupancy usage. Harvested rainwater stored in 660-gallon tank per duo will provide water for toilet flushing and clothes washing. Grey water collected from showers is used for garden irrigation. For the hot water, 1 air source CO2 heat pump with an 83-gallon tank provides hot water per duo, with no water utilities on the first floor of the residential blocks to reduce plumbing infrastructure. Building science control layers were selected to suit Oakley East's climate. Effective insulation layers were used to reduce heating loads. A vapor-impermeable biomembrane on the interior layout before the plasterboard prevents warm air from inside leaking into the wall cavity, where it is at risk of condensing in cooler weathers. The vapor-permeable water-tightness external membrane allows any warm air that does escape into the wall cavity to exit to prevent mold formation. Both these membranes are also air and watertight, preventing them from entry both internally and externally. These membranes create a continuous seal across the foundation, walls, and roof of the buildings to create a strong thermal vapor, air, and water envelope. To further increase the durability of the refuge over its 50-year lifespan, locally sourced Australian materials were selected to withstand Melbourne's climate conditions. Some examples include fiber cement cladding, which is low maintenance and durable. Colorbond steel roofing is hail resistant, easy to install and replace, and is flame resistant. Concord tiling is made from recycled cork and can be installed as tiles to allow for rotation between high and low use areas to extend the life cycle of the material. Glass wall insulation is non-combustible to protect against fire, and finally, earth-friendly concrete provides a strong foundation for the building. These materials, alongside the renewable energy battery system, protect against the biggest threats of fire, storms, and electrical blackouts. I will now hand over to Jamali for the recovery part of our project.
The Recover and RE represents our desire to help the women and children recover while in the refuge, while also seeing the continual recovery of the environment. To give you a bit of context, the building lifespan is estimated to exceed 50 years, as most refuges aren't renewed or renovated by the government frequently at all. So when choosing our materials, we prioritise locally sourced materials and lightweight construction to overall minimise the emissions involved in building the refuge. We wanted to use renewable and recycled materials where possible as well, giving the entire complex a circularity of about 45%. A key consideration for this when looking at the embodied environmental impact was the large cement slab we use for our foundation. To minimise the emissions involved in this, we used an earth-friendly cement that has 45% lower emissions than traditional Portland cement, and we also used a waffle pod grid to greatly reduce the amount of cement we actually needed to build the slab. And with all these factors considered, we found that our biggest impact on climate change would be due to the electricity we need from the grid, because Victoria's grid is heavily based on coal and emits a lot of CO2. So given this, it was very important for us to reduce our reliance on the grid. Given Melbourne's sunny climate, solar was the obvious option for us, and we tested two systems. We tested a 65 panel system which produced 24 kilowatts of energy, and an 86 panel system that produced 32 kilowatts of energy. We ended up going with this larger one because it reduced our dependence on the grid to only 16% across the whole year, and over the lifespan of the building would actually save 140 tons of CO2 when compared to the smaller array. We coupled this larger array with 4 10-kilowatt-hour batteries to help Cara House have maximum flexibility and adaptability depending on the occupants' different usage rate, because that will be changing all the time. Additionally, we also wanted to implement a peer-to-peer virtual power plant system that allows Cara House to export excess solar energy, especially in summer, to nearby transition housing to overall reduce Cara House's carbon footprint even more. And also by providing them more funds, this will save them about $50,000 over 20 years. And this made the additional solar panels a justifiable upfront cost. The energy modelling showed that only 84% of our energy was produced on site. Through software like Design Builder, we were able to actually get our heating loads down to 820 kilowatt hours a year, and our cooling loads were 3,434 kilowatt hours a year. The HERS index, we did this by assessing one single apartment, which had a HERS score of 48 without PV, and the entire multi-purpose complex, which had a score of 49 without PV. When considering PV, the single unit score went down to -2, and the multi-purpose space went down to -22. And the true HERS index score will be somewhere in between these two values, because the analysis tool didn't recognize the batteries and also didn't account that the solar panels would be splitting their energy evenly amongst the apartments, even though the multi-purpose space has a lot more panels on its larger roof size. We also wanted to have a comfortable and quiet living space, especially because these women and kids are recovering from intense trauma. We wanted to give them privacy and be able to maximize their recovery. The Hvac systems implemented were centralized across 2 units, with the ducting and fan coil unit going across the ceiling or the attic cavity, depending on each story. 2 fan coil units will be supplied by 1 Daikin reverse cycle air source heat pump to meet a duo's full heating and cooling needs. For this, each room is supplied with conditioned air, as shown here. and maintaining a comfortable year-round temperature of about 72 degrees Fahrenheit. One heat recovery ventilation unit is utilised for each story across the two units to achieve a maximum of 0.77 air changes per hour, and there were exhausts in the wet areas and supply everywhere else. F7 filters were also used in the HRV system that ensure fresh air is provided, free of bushfire smoke and other pollutants that you might find in Victoria. Similarly, appropriately sized appliances were also used in the disability space and the multi-purpose space and staff room. The interior and exterior walls also use ceiling insulation that is acoustically insulating. By up to 75%, it will reduce the noise. Glass wool insulation has been used on all adjoining walls, as shown in purple here. Anyway, I'll now pass you over to Xian, who will talk about the last bit of our focus.
The empower aspect of our project lies in empowering not only the women and children staying at the refuge, but also Cara House in the operations and the government agencies in encouraging them to build more net zero purpose-built refuges. A key consideration of our design was ensuring financial feasibility while also allowing our design to be as flexible as possible. The estimated construction cost for Project RRE is $2.4 million, which is below the $2.7 million budget as advised by Cara House. The decreased operational and maintenance costs, as well as the savings from the solar virtual power plant, reduces ongoing reliance on fundraising and government funds. The majority of the building costs are associated with construction, while the solar panels are only 15% of the total cost and have a payback period of 7 years. Hence, this project is an efficient use of government funds, allowing for more similar refuges to be built in the future, especially given that the Victorian government has announced a $114 billion family housing blitz in 2016, and more recently an additional $4 billion commitment to social housing in 2020. This design has great potential to implement effective change. One of the key points from our design partner Cara House was the flexible use of the dwellings. For this, we designed the Occupancy Maximizer layout, as Lucille mentioned earlier, which is achieved through an insulated operable wall. These effectively work in duos of units to modulate from a standard 2-bedroom unit, as highlighted here, which can accommodate 1 woman and 3 children, to a 1-bedroom for a single woman with an infant, or to a 3-bedroom for a woman and 4 children. The accessible unit has an additional 2 bedrooms and provides the adjacent unit with access to the upstairs bedrooms, allowing for a high occupancy unit which can accommodate 1 woman with at least 9 children, to the use of bunk beds. Currently, this demographic is being underserved, as most refuges can only accommodate small family sizes. This configuration allows the accessible unit on its own to house a woman and 2 children. Overall, this allows Cara House to be flexible and empower other refuges to follow. Within the refuge, systems have been designed to ensure the complex is easy to maintain with a low-maintenance exterior and native vegetation. Centralized controlled and programmable keycards gives Cara House control over the refuge operations. The units have been designed to be comfortable for the occupants but also easy to manage during occupant turnovers. Green spaces have been incorporated throughout the complex. Within the design of the communal garden, the attention restoration theory was used to create spaces that allow occupants to divert their attention from the stresses they are experiencing and focus instead on the present. Textures, color, and fragrant plants have been included to engage occupant senses as they enjoy the outdoor garden. The unit layout was optimized to suit the orientation of each block. Natural lighting has been prioritized for both orientations, and both upstairs and downstairs living rooms have been designed to ensure that each block has a north-facing living space. For the building subsystems, automated components ensure the energy systems operate efficiently on their own. Centrally controlled components allow Cara House to control the internal conditions of the units, keeping the complex secure with camera monitoring and turning off power to a unit when it is unoccupied. Finally, to provide a sense of control, occupants are able to manipulate internal lights and blinds as well as their appliance usage. This now brings us back to our principal objective of providing purpose-built, safe housing for domestic family violence-affected women and children. Through this design, SafeLink hopes to bring net zero concepts to the public housing space, showing its feasibility and sheer effectiveness in being environmentally friendly. We at SafeLink believe our design truly helps its occupants rest, recover, and be empowered. Thank you.